Okay, guys, I had to get this one ready for you. We're going to do current and Ohm's law. Current is just the flow of charge, which is coulombs per second. Write down the notes and pause it on the cruise and do that. Pause it again. We'll go over those. All right. So you pause and you got all the notes down, okay? Okay. Now, let's go back through this and see what the notes say. Current is I equals the delta Q divided by delta T, where delta Q is going to be the charge, flowing through a cross-sectional area. And the time, delta T is the time at which it takes to do it. The units, amps for current, coulombs, time, blah, blah, blah. Here's like a piece of wire, cross-sectional area. The time it takes for a certain amount of charge, delta Q, to flow through a cross-sectional area, okay? Coulombs per second, amps. You could have an example here, which you should already have written down. The current in a light bulb is 0.835 amps. How long does it take for a total charge of 1.67 coulombs to pass the point in the wire? Very simple to do. Let's see. I, delta Q over delta T. Isolate your variable. Let's see. Delta T. And let's see. What are your givens? Current. It's going to be 0.835 amps. And let's see, your current or your charge. 1.67 coulombs. All right, plug and chug. Isolate your variable. And just pop it in. I can't remember what you get on this one. Let's see. 1.67 divided by 0.835. I think it's 2 seconds, as I recall. If it's not, that's close, okay? All right, that's how that equation works. Now let's do another one. Okay. Ohm's law. Write this stuff down. This is just a battery here showing if you connect a wire here, it'll leave the positive in the battery come around to the negative, because current is about positive flow, not negative flow. So you put voltage in the battery, it leaves the positive and it's drawn to the negative end, okay? Positive flow will find negative charge, and it does. 1 volt is 1 joule per second. That means for every, 1 volt is 1 joule per coulomb. That means every coulomb that passes through this battery gets up by 1 joule. Let's say you have a 10 volt battery. That means if 1 coulomb passes through, you get 10 joules of energy. If 2 coulombs passes through the battery, it gives 20 joules of energy. All right? Okay. If you got to pause, guys. Where does voltage come from? Well, basically a separation of charge produces voltage, and I'll leave it at that. Okay. Just like we did on capacitor plates, if you charge up a capacitor, positive up here and negative down here, okay, and you put a positive charge on this plate, on the top plate, and you pull it away, you let it go, it's going to go towards the negative plate. It'll gain kinetic energy. Okay. Well, and it will get, thing on this. If you let a coulomb of charge pass through, it will gain, let's say if it's a 10 volt separation, it'll gain 10 joules per coulomb that passes from one to the other. Well, that's an idea of what voltage is all about, okay? All right? But you already had some stuff on voltage anyway, so yeah, sorry about that. Okay. And Ohm's law says delta V equals IR, or we just say V equals IR. In other words, this is about a resistor. These are all about resistors, okay? This about when current goes through a resistor in a circuit, okay? The current through the resistor times the resistance of the resistor equals the voltage drop in the resistor. That's all it's saying. And most of you guys have had this last year. If you haven't, it's not very hard. Okay? Once again, V means delta V. The drop in voltage as you go across a resistor. The current times R, once again, is delta V. Okay. And a simple circuit looks like this, very simple. Okay. Let me do this. There you go. Simple circuit, a very simple circuit. This is what we call schematic. The small bar is always the negative pole, and the negative plate or the negative pole of the battery. And the long bar is called is going to be, I'm sorry, negative and positive. I'm sorry guys, I'm tired. This is your battery, where your voltage comes from, positive plate, negative plate, or positive pole, negative pole. It's not a capacitor, it's a battery, or a source of power. Okay. It may be an outlet, something like that. Okay. Here's your resistor here. Once again, current will leave the positive pole, and it will go around this way and find the negative end, but it will go through the resistor as it does that, okay? So here's what's going on here. We put voltage in at the battery, we get voltage out of the resistor, okay? And whatever, as you go through one loop of a circuit, no matter what it looks like, no matter what components are in there, voltage in must equal voltage out. If you put 10 volts in here, you got to get 10 volts out in the resistance, all resistance together, okay? Okay, now, that's called Ohm's law, by the way. V is voltage drop across resistor. I is the current in the resistor. It's in amps, of course. R is the resistance of the resistor. It's in ohms. This is like a horseshoe, uppercase omega. All right. I'll pause it because I'm going to keep cruising, guys. Now, that's called Ohm's law, and this is true for every resistor. I times R will equal V or delta V, guaranteed. But there's another point here to be made. Let's say we manipulate the equation. We have V over I equals R. We just brought I down, okay? Here's the deal. If V over I is always your resistance, okay? But here's the deal. Let's say we double the voltage. And when we double the voltage, let's say we also double the current. So R stays constant. Now, some resistors do that and some resistors don't do that. In other words, some resistors, once you find the resistance at one voltage, that's the resistance at every voltage. It doesn't change. That's called an ohmic resistor. So if you double the voltage, you double the current. If you triple the voltage, you triple the current. Okay? Ohmic. Some, if you double voltage, you will only 1.5 times the current. That's not ohmic because R is not constant. In our class, we only deal with ohmic resistors, where once you find the resistance under one situation, it's the same under all situations, if you change the voltage. Okay. Now, for the most part, we do that. Okay. Yeah, and there are different ways to define V or delta V. Voltage, potential difference, electric potential, voltage drop. Now, some will say, well, potential difference is not potential. That's basically true. Potential means the voltage at a certain point. Potential difference means the change in voltage when you go from one point to another. But having said that, I don't worry about it. You use enough, you know what you're talking about. Look it up. Good on that. Okay. Let's do a problem with this, guys. Let me find one real quick. Where I'm at, documents. Where's my book? And chapter 19. And what page? There it was. Let's do this resistance. And there's the problem right there. Let me do one thing real quick, guys. Blow that back up. There you go. Write this down. We're going to do this as an example. There you go. The resistance of a steep iron is 19 ohms. What is the current in the iron when it is connected across a potential difference or voltage of 120 volts? Your R is obviously 19 ohms. Your delta V or V is 120 volts. That's for your current. And then I set the very old simple problem to do, right? Plug it all in, you get 6.32 amps. That's it. Okay, guys. I'm going to give you a bunch of worksheets, put them all online, get them all done. We're going to go through up to Kirchhoff's rules, and once again, I will do RC circuits with you. That's it.